Let's take a look at a few examples. So first example, we'd like to do some indefinite integration or find the antiderivative of 5x cubed plus 3x squared minus 7. All of this is going to be with respect to x. X is our variable. Now, if we think about the rules that we had last time, we could use all of these rules to start to simplify this down. So you could see this now as separating this with the adding and subtracting, right? We had that rule that says if you're adding and subtracting them, you could deal with each of them separately. So this could be the integral of 5x cubed dx plus the integral of 3x squared dx minus the integral of 7 dx. One thing, notice here that I have dx's everywhere. Every time you have this integral, you have to have a corresponding dx or dy or whatever variable you're using. But these two always have to go together. It's kind of this like sandwich. They have to both be present. Now we also had the rules about if you have a constant times a function, you can pull out these constants. So you could take the 5 outside and you have the integral of x cubed dx. You could do the same thing with the 3 and you're left with the integral of x squared dx. And then we're just going to leave this one because we had a rule for a constant. So if we remember the rule for these x's to a power, we add 1 to the power, divide by that new power. So this becomes x to the 4th divided by 4. But I also have a plus c, right? So I have 5 times x to the 4th over 4 plus c. This is my result I get over here. Over here, I have the 3 out in front, and then I add 1 to the power to get 3, and I divide by the new power, and I have plus another constant. Now, technically, these are different constants, so we would use subscripts to indicate this. So we'd have C1, we'd have C2, and then over here, for this, I would have minus 7x plus a new constant. So the integral of 7 is 7x. Now, you have a lot of constants here, and they all are just an arbitrary constant. So if we think about if I take a constant, say 5, I add it to another constant, say 7, what do I get? Well, I get another constant, right? A constant plus a constant is a constant. I get something like 12, right? You can't combine constants to make something like a variable, right? I couldn't combine 3 and 7 and get some type of x, right? So what we're going to do to simplify this is instead of having a plus constants appear everywhere, we could just do at the very end one single constant. That's it. So instead of this, what we could have done is we could have had 5x to the 4th over 4 plus 3x cubed divided by 3 minus 7x plus a constant. And so this is going to be much more of what we're going to be used to seeing, is that we'll just say, okay, if I multiply a constant by 5, I get another constant. If I add it to 3 times another constant, I get another constant. I subtract off another constant, I get a constant still. So that's all we're doing. We're just combining it to a single constant. So there we go. This is what we have. Now, once you get the hang of this and understand the rules, you could go from this step to this step. So we will get to the point where we don't need to simplify and separate them by these rules. So if you want to try to practice doing that, feel free to continue practice. Feel free to practice that as soon as you want. So now if we look at this one, just like with derivatives, this gets a little bit tricky until we realize that these are just exponents of x. Right? So if we look at this is the same thing as x to the 1/2 power. And here I have 1/2 times x to the negative 1/2 power. Again, one thing just real quick, notice that I'm also using equal signs along this, that this integral is equal to this one, which is equal to this one. So use your equal signs. Now if we think about the rule that I said we have to add 1 to the power of x, then divide by that new power. So this would be x to the 3/2. So I add 1 to 1/2, I get 3/2. Now I divide by 3/2. Here, if I take a constant and I'm multiplying it by this function, when I take the integral, I'm only going to be having this really be dealt with and changed, this constant just going to stay there in front. So I have plus 1/2 times x to the 1/2. So I add 1 to negative 1/2, I get positive 1/2. Now I divide by this power of 1/2. And then at the end, remember, you have your plus c. So you could simplify if you want, knowing that if you're dividing by 3/2, you're really multiplying by 2/3. Right? So we could see this as 2/3 x to the 3/2. And then this, if we're dividing by 1/2, we're really multiplying by 2. So if I take 2 times 1/2, I just get 1. So this would be plus x to the 1/2 plus c. So this could be our answer here. So again, with the constants, you could do the same thing up here. You could simplify the 3 divided by the 3. You could have this be 5/4. So you just deal with the constants the same way that you normally would. Here, now remember, I said we didn't have a rule for division. We don't have something that allows us to say, okay, this, if I'm dividing this function by this function, how do I deal with this? We have to rewrite it in some type of creative way. So if we remember, what we're allowed to do with these variables is you could divide each of these by x to the 4th. So this would be 1, x to the 4th divided by x to the 4th is 1. I think negative 3 x squared divided by x to the 4th, this is going to be minus 3 x to the negative 2nd. Right? You just subtract your powers of x's. And then the same thing on the third one, I get plus 5 x to the negative 4th. So now I have clearly exponents of x. So similar to what we did over here, we could separate this if we want. But again, I said we just wanted to get to the point where we're really practicing this at the level that we want to be. So the integral of 1, this is just going to be x. I have minus 3, and I think the integral of x to the negative 2nd, well, I'm going to add 1 to the power, and then I divide by this power. So I add 1 to the power. To get that, I divide by negative 1. And I do the same thing here. I have 5, and I do the integral of x to the negative 4th. I have x to the negative 3rd divided by negative 3. And again, don't forget your plus c. So we could simplify this to be x plus 3 times x to the negative 1 minus 5/3 x to the negative 3rd plus c. So reminder, this is a function. This is the group of all of the functions that when you take its derivative, you get this. So if we were to think about each of these, right? So maybe if I was to look at this one, again, we're thinking I could take the derivative of this and get back to this point, right? I take the derivative of 5 times x to the 4th over 4. I bring down the exponent of 4. 4 divided by 4 is 1. I get 5x cubed. Good. Take the derivative of this with respect to x. I bring down the 3. That cancels with the 3 on the bottom. I have 3x squared. That's good. Take the derivative of negative 7x. I get negative 7. Take the derivative of a constant. I get 0. So with this process, you can always check your work by going backwards. So this last one, now y's, this is just the same thing as if they were x's. It doesn't matter what letter, what variable I'm using, it's still going to be the same rules that apply to it. So when we look at y squared, I add 1 to the power, and I divide by that new power. If I take tan x y, or tan y times secant y, what function, when I take its derivative, gives me that? Well, again, if you remember things about tangent and secant derivatives, you remember that this is going to be the derivative of secant. So this is going to be minus secant of y plus a constant. So those are some practice problems to get you hopefully comfortable with these rules and understanding how do we apply all of these at once.